first speaker of the day, I really asked for a super warm welcome because it's the first time in Italy, and I remember the first time I watched his video on TED, I thought, oh my gosh, it can't be for real, you know? And this man is the man behind all the Minority... Do you know Minority Report, the movie with Tom Cruise, with the gloves, you know, unbelievable movie, and he's moving things around with his hands. And this man is the man behind that technology, and he did it for real. So that's amazing, I think. So please, a huge warm welcome to John Underkoffler. Hey, John.
Buongiorno. Buongiorno. Grazie. Well, thank you for your time this morning. I think we have some interesting things to talk about for about 20 or 25 minutes. We're going to speak, yes, about Minority Report. There's no escaping that movie, even though it's 11 or 12 years old. But we're only going to speak about it a little bit, because it is, after all, in the past, even though it looked toward the future. But it is the past. And we're more interested here in this room, I think, in the real future. We're going to talk about design, that most fitting of all human pursuits. Design is what takes us from the past to the future, and after all, we're in this magnificent museum in a magnificent city. And the title of this entire conference is Redesign, so we'll be talking about design. But really, today, we're going to talk about computers. That's not a very fashionable word anymore, computer. Right? I don't think I've heard anyone use that word in the last 24 hours, and yet computation is the medium that brings us all together. That's what we're talking about for these 2 days. So why do we not use that word anymore? I think we may have something interesting to say about that. I'm going to propose that, in fact, at the very beginning of the modern computer era, in 1984, let's say, when the Macintosh delivered to the world the very first graphical user interface, or GUI, we kind of gave the machine the wrong soul, or we gave it an inadequate soul. It was fine at the time, it worked well at the time, but what was that soul? Again, the soul of a computer is its user interface, its HMI, its UI. The soul that we gave it, the UI that we gave it, was very clerical. The stuff on the screen, the little icons, the trash can, it was about files, it was about moving pieces of paper, except digital pieces of paper, from here to there. A clerical operating system, a clerical UI. It's like a Franz Kafka character. And that's what the machine believes that it is. Now, that has gone on for a long time. That's gone on for 30 years. We haven't changed that. And I think maybe we should have, because what's happened since then is that we've invented the web, which we love, and then we invented the cloud, which we also love, and we took all of the stuff that used to be literally under our fingertips, our stuff, your stuff, my stuff, and moved it farther and farther and farther away. So there is an interesting problem here, which is that the stuff that we like has gone away from us. And in fact, I think the conclusion is that we don't like the computer. We've exiled it. We put the computer into the cloud. We sent it to its room. We don't like to have it near us. And instead, we talk to it using toys. These are sort of computers, but really they're children's computers, they're toys. And that's more comfortable. These are great, we like our tablets and our phones, but the question remains, why can't we have real computers near us? What is the stuff that we should have here? Yes, we still want the cloud, we want all of that power and the computation, but can't we have something more here? And the entire idea behind this talk, and I'm almost finished with the entire talk now, is that we should give the computer a new soul. And the soul of the computer should be design. The computer should believe not that it's a file clerk, not that it's helping us move pieces of paper. It should believe that it is helping us with projects in architecture. It should help us with composition, with music, with filmmaking, cinema. All of those activities, those human activities, can be supported by a computer's operating system and its UI. And if we build the computer like that, then of course it can still do all of the clerical stuff, the spreadsheets, the databases, everything that we use them for today. But I maintain, I propose to you, that that new machine with a new soul will be vastly more capable and vastly more human. So let's take a look at some design. We'll spend only a little bit of time, as I said, on Minority Report, but the idea, I think, is that this film remains the single best cinematic prediction of the future. Now, why is that? The answer, again, is design. The production designer for Minority Report was a remarkable guy named Alex McDowell, the world's most legendary production designer, I think. And when Steven Spielberg said to him, I want the audience to believe that this is 2054, that this is Washington, D.C. in the United States, 50 years in the future, Alex said, yes, sir. And he went at that project using a technique that he calls world building. And the idea there is to build the entire world, to know everything you could possibly know about that fictional future world. Don't just design enough that you can film exactly the scenes that you need. As it happened, when Alex started designing the film, there was no script, so we didn't know where the film would go. I was very fortunate to be invited to serve on that film as the science and technology advisor, so I was in charge of making sure that all of the futuristic stuff, the gadgets, the technology, fit together with the rest of the world. So we designed an entire world, way more than could possibly fit in the film itself. This is the Minority Report Bible, so-called, and it was a compilation of all of the research, all of the design that we put together to ensure that this new world of 2054, although here it says 2080, would be believable, and it encompassed every aspect of the world. Ecological aspects, we said that in the future we had solved a lot of pollution problems, things were green, cities were smaller but higher, no internal combustion engines. Advertising, it's an advertising saturated society. This is what drives the economy. Technologies for the home, new kinds of cooking surfaces that can be hot 1 minute and cold another minute. How are you going to cook in the future? Personal information technologies. That one looks a little familiar. So we weren't able to see 50 years into the future. This one only took 10 years. And in fact, that's true for a lot of the things in the film, that we did our best to push forward 50 years. Transportation technologies for everyone. Transportation technologies for specialized purposes, for police. Strange technologies for collecting brain images from poor psychic children who predict the world's crimes. And then lots and lots of stuff that didn't fit in the film. Our design process is littered with stuff like this, not because it wasn't a good idea, but because it just didn't fit in a film. The film is a very small object, only 2 hours long. The idea here was that the future would have robotic paparazzi, so they would fly around to interesting sites of news, crime scenes or sporting events, and they would literally jostle with each other for visual access to the scene. So there's so much world that Spielberg could have pointed his camera in any direction, literally or figuratively. And that is the reason that any thread that you take through that world feels like the real world. It feels believable. It feels like if you go around that corner, there's more world. And that's very rare for a film. Right at the end, we got downgraded. Spielberg said 2080 is too far in the future. No one will believe that. Let's say it's 2044. And then right before the film came out, the producers increased it to 2054, so there was a lot of very complicated voice dialogue replacement to make the math come out right. One of the things that I spent the most time on myself was the kind of information core of the film. Spielberg wanted to know what computers would look like in 2054. He said, I don't want to see keyboards, I don't want to see mice, no voice recognition. What can we make this stuff look like? And he loved the idea, when we proposed it to him, that computers could be driven gesturally, using human hands. So you could stand like a conductor, the conductor of an orchestra, in the middle of this enormous panoply of screens, and point to what you want, and move it around, and use your hands the way they were evolved to be used as dexterous instruments. So we went to work. We designed a completely new computational language, a completely new UI, a gestural UI, and we studied international sign language and SWAT team commands, and all of the gestural systems that humans use to speak with each other and communicate vague intent, such as when you gesture while you're talking, or specific intent, if you're a ground air traffic controller, and so on. And we synthesized a language that would be appropriate to the needs of the film. And we wrote and published little dictionaries or thesauruses, made training videos. And what that meant is that when it came time to film these scenes, even though the actors saw nothing on the screens, they knew how to use this new gestural language. They were experts. And what's interesting is that people are still talking about these scenes 11 years later. Something about this made it stick. Something about this resonated with people. And part, I think, of what's exciting here is that, yes, it looks like there's lots of pixels flying around, and that's visually exciting, but there's something else. It's operationally exciting. It's causally exciting. you can see that these characters are getting something done. They're getting work done. And as audiences, as people, we love process. We love to see how something evolves, how it changes, how human beings manipulate it. And you can believe when you watch these scenes that there's real work being done. In fact, Spielberg was so excited by the early scenes that featured only Tom Cruise that he asked for new scenes to be written so that Colin Farrell there and Neil McDonough earlier could also use this technology. So the technology itself expanded throughout the film. So we all know these scenes. I'm going to leave them behind. What is interesting, I'm going to propose, is that accidentally, in a way, we were able to use the Hollywood machinery, the filmmaking machinery, to test a new technology, to test a new real-world technology that we might be able to build. That's what I was thinking when we were doing this film. And in fact, we had the largest user group you can possibly imagine for any new technology. I don't know how many people saw the film, 10, 50, 100 million people? That's a very large user group, better than you can expect for most kinds of products. And people liked those scenes. They liked them so much that they started calling and asking if it existed, and if it didn't exist, could it be made to exist? I'm going to take one more dip back into Minority Report because there's something that people don't talk about as much as they talk about the gestural computing scenes, but it's the real core of the future. It's the core of the future that we have to pay attention to and that we have to believe in. And that is, as we were designing the film, we said display is going to be everywhere in the future. There's going to be pixels everywhere of all conceivable different kinds. And that has come true even faster than anything else that we predicted in the film. So in designing the film, we predicted there would be display on clothing. This is a kind of information switchblade that you can whip out like a knife and get just enough information to do a shopping list or something like that. I don't understand what the webbed finger display was for, but the bracelet is nice. This is a kind of hand taco, a communicator that you can pull off your wrist. There was supposed to be an enormous fashion show in which all of the models would wear clothing that displayed what was being seen around them. And then, of course, the police came and destroyed everything. Medical imaging displays, city-sized displays for wayfinding, for advertising, displays for entertainment, and so forth. And, of course, again, this central display that is for information processing. That is true. That has come true, whether we like it or not, and I like it. There's display everywhere. There's pixels everywhere. It's exploding. There's more and more and more pixels. So if that's true, then we can follow a few logical steps and conclude something about the future of computation. If there are displays everywhere, and we want to be able to work with the pixels everywhere, the pixels there, and the pixels up there, and the pixels here, and the pixels on this thing, then by definition, there can't be just one computer driving those pixels. There aren't enough outputs on the video card, there's not enough CPU cycles, there's not enough of anything. So clearly, there's more than one computer driving all of these pixels that we want to have work together. Therefore, the future must involve programs, processing, programming, and applications that run across these pixel sets but do so believing that they're one program, even though they're operating across lots and lots of CPUs. That's an interesting proposition. It's a new kind of distributed operating system, but one that's thinking about pixels and thinking about UI and thinking about display, not thinking about CPU. So it became clear that we had to build this stuff again. We'd built it once at MIT. We don't have time to talk about that, but that's the original work that came into the film. We built it in Hollywood in a fictional sense. It didn't actually work, except that the actors knew how to use it. They were the very first users of this new technology. We had to build it a third time. And we had to build it in a commercial context as a startup. That's how you get new ideas out into the world, by making them, turning them into products that people can use, technology that people can use. So we formed Oblong. Oblong Industries is a Los Angeles-based company with offices in many cities around the world. And we built GSpeak. GSpeak is the real-world version of the distributed operating system, the gestural spatial operating system that we saw in Minority Report. And it's better than in the film because it actually works, and it's really fun to use. So let's take a quick look through some of the principles that guide our design of GSpeak. This is only one version, I should say, one version of the design-led idea of what the soul of the machine could be. But it is our optimistic version, our enthusiastic version of what this future could be like, and it's being tested and used by many, many companies today. So, 4 principles. The first principle, hands and space. Computers for a long time have been too abstract. The pixels believe that they're in a kind of abstract integer x and y zone. That's not true. The pixels are actually here in the room with us. Every pixel you see has a position in the room just as surely as we do as people. Let's talk about hands. Human hands are arguably the most dexterous manipulatory instruments in the world. They've evolved over 10, 50 million years to do what they do, and they can do it like nothing else possibly can. And therefore, both input and output, we can manipulate the world, but we can also understand the world by touching it, by moving it, by changing it. So our new operating system, GSpeak, has to understand that pixels live in space, and that hands are a very good way for addressing pixels. In fact, you can stand back from pixels and point at them, and yet be very precise. So here we'll take a little look at what some of that can mean. These are just test and demonstration systems right now. But by pointing, you can step back from a screen, and more than one person can do this at the same time, and grab elements, move them around. And you can move them from screen to screen, in fact. They don't have to stay on one screen. They can be brought to any other screen that you like, because the middle of the room is the one place you can stand and address every screen by pointing. You can touch if you get close. Of course, touch is just sort of a subset of 3D spatial input. You can gather, you can scoop, you can sort, and you can grab virtual objects and pull them toward you. I should say, all of this stuff is real. This is not like Minority Report. This actually works, and if you come to our lab in Barcelona or Los Angeles, you can play with this too. Sometimes the pixels are actually physical, and they should work just like the light-emitting pixels do. Navigation is a critical idea. Three-dimensional space is a place that we have evolved as human beings to understand. We move through it, we use our eyes to understand it. So if you can place data, abstract data, literal data in 3D space, you have the best chance of understanding it as a human being, especially if you can also fly through it. Annotation, you should be able to draw wherever you want. Now this is actually a professional application that we've developed in the field of oil and gas exploration. And these are data sets that are so big that nothing else can solve these kinds of problems. Not more AI, not faster CPUs. The way to solve the problem is to increase the bandwidth between the computer and the human brain. And you do that with a better user interface. You can draw in 3D space. Medical imaging, all of these are spatial, dimensional tasks, and we need the best possible UI to allow people to understand what's going on. It's an air traffic control simulation, tens of thousands of flights all in the air at once. And the best way to understand is to move around it, just as you move around the real world to understand it. And we can do it without the gloves as well, although the resolution is not as good. So here's a visualization of earthquakes, seismic activity. And many people can use these systems at the same time. When you step back from a screen, there's more space. There's physical space and there's social space for multiple people to work together. So these are slices through GSpeak. These are basic demonstrations of the core capabilities. The second principle, and this is kind of something you should always hold in the back of your mind as you design new systems, is aesthetics. It's maybe synonymous with design, but if you get aesthetics right, then the experience of using the system is exhilarating. You should feel when you use new kinds of systems that you're connected to them, that you have a very real kind of power. Not brutal power, but sophisticated power. The power of creation, of synthesis, the power of pulling pieces together. And in this example, we have about 18 films imported into a system called Tamper. And we allow users to reach into the films and pull out individual elements. And you can bring them down to a desk, to a composing table. You can then touch the pieces to move them around. And then you can go to a completely different film, pull out a separate element, and place it into the composite as well. This is real again, I should say. Thank you. And what's important here is not so much that maybe this is the future of editing and film construction. Maybe it is, but really for us, this is a metaphor. This is how using computers should be. It should feel this exhilarating, this powerful. You should have direct control, sophisticated control over your own stuff, your media, your data, your communications. It should be in your hands, literally. And of course, we can move big chunks of pixels from screen to screen, as you see there. The third principle is that I think we're on the verge of a very, very large change. We're so close to it that we can't see it, and it's about to happen nonetheless. And that is, we've been very well trained over the last 10 years, 15 years to love our devices, and these devices are indeed beautiful. But what's wrong with these devices is that the applications that run on them, the communications, the data, the apps, stop at the physical boundary. And that is a strange and artificial limitation. In the future, what we'll care about is not so much the devices, but the pixels. The pixels are where the stuff lives. The pixels are where the work lives. The pixels are where the play lives, the communications. That's what we want. We want pixels to do our bidding, to work for us. We shouldn't care so much about the devices. And so we're about, over the next 10 years, I think, I'm predicting this, to care a lot less about pixels and in fact be able to use aggregates, constellations of different devices, different pixel sources to get our work done. And this is a simple demonstration of that. Here are 5 different screens driven by 3 different computers and 2 operating systems, and this little bit of media can be driven to run around them consistently. It's all synchronized in time and space. And when you write this program in GSpeak, you write one program and you don't tell it how many screens or how many computers. If you add another screen, then the application can simply expand onto that screen. This is the future of how people will write and use applications. If you need more space to get your work done, you add more pixels. Similarly, here's a bit of data, a 3-dimensional model of a tree being moved from a Macintosh to a Linux machine, gesturally, using a prime sense sensor, and then another tree is being moved back. We switch sensors. We're now using a leap motion device to perform fine-grained control over the simulation that grows the tree. So multiple screens, multiple operating systems, multiple sources of pixels, multiple people, and maybe even multiple different input modalities. That's a big change and a really important change. The question is not which device will we use or which operating system will we use. The answer is that we'll use whatever we need, whenever we need it. And the operating system that wins, or the applications that work the best, will be the ones that don't care. The ones that work across this device and this device, that flow from this screen to that projected set of pixels. Finally, there's another artifact, another limitation of computers that's artificial and unfortunate, and it's been with us so long that we almost can't remember that it's true anymore, but it's that one computer can only be used by one person at a time. It's a very strange idea. Everything else that we do in the world, or many other things, allow people to work together. We can all stand at a whiteboard together and draw together. We can sit across a table, 4 of us, 10 of us, and speak. We can mold clay together. But when you use a computer, it's one person, one computer. That's a strange limitation. That must come undone. The future must allow for multiple people to use the same system or the same constellation of systems at the same time. And I'm very pleased to show you here today Oblong's first broad market product, a product called Mezzanine. And it's intended to change the way people work together when they're in conference rooms or meeting rooms. Today, conference rooms and meeting rooms typically have 1 or more high-definition displays, but those are very limited devices because they have a single simple cable that comes out, and whoever grabs that cable first gets to bore everyone else with PowerPoint. In a mezzanine system, every device in the room is a control surface and a content surface for controlling the big screens. Everyone works together on the big displays simultaneously. So here you see someone selecting content, sending it into the mezzanine system, and then it becomes part of the shared workspace. It's then manipulable by anyone else that's in the room or in any other mezzanine room. We use spatial wands that are like the gloves, but a little bit more hygienic, and you can use those to drag content around. Any device is respected to the full measure of its capabilities. So this device has a built-in camera, and that means it's a new way for content to get into the system. You simply photograph something, it becomes part of the shared pixel workspace. You can bring in telepresence or VTC simply. We've all been in telepresence or VTC rooms. Those systems take over the whole screen, and that's great as long as what you want to do is talk. But the minute you want to get actual work done, then seeing someone else's face is not the most important thing. At that moment, it's important to be able to put the people off to the side and get back to the work. The whiteboard is a perfectly great piece of equipment that exists in many meeting rooms. We don't need a digital whiteboard. What we need is a way of importing that content. So simply by pointing the wand at the screen, at the whiteboard, you can import it into the system, so it becomes a first-class citizen. So what you see here is a system for performing work, creative work, decision-making work, in a shared context where there's no leader, where control can flow from person to person, just as conversation and ideas can flow from person to person. And it changes the meaning of the pixels, and it changes the efficacy, the efficiency of meetings. You can grab subsets of devices, you can drag content around the room from screen to screen to screen to screen. And when you have a connected laptop, you can use the wand to reach through that screen and control the laptop that's originally generating the content. So it's a kind of application or capability syndication. One person has an application on her or his laptop. Everyone in the room now has that application. And we can bring in remote participants. So people in a completely different location have a completely shared democratic access to the room. And we can connect up to 4 different mezzanine rooms at the same time. In this situation, you see 3 different rooms being connected. So this, I think, is the way we will all work. This is the way we should want to work. Not serially, but in parallel. Not linearly, unless we want to, but non-linearly. Not in an isolated state, but in a collaborative state. So I'll wrap up here. If this were a general audience, I would say you should ask this of the people who are building the future world of computation, but you are the people who are building the future world of computation. You are the creators and you are the entrepreneurs. So I would ask you to build like this. Build systems that embody meaning, real meaning, deep meaning. Systems that allow concentration, that let people go as deep as they want. Systems that are not objects of distraction. These are fun sometimes, but you can't get all your work done on them. Systems that amplify human intent. Systems that are like giant exoskeletons for the human will, the human creative will, and creative gives us synthesis. Systems that are about making new things, not consuming old things. And finally, systems that more than anything else embrace what's most important, which is humanity. Grazie.
Guys. Stop, 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 stop. Stop, 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 stop. More. Great, John. Seriously, I'm impressed. No, seriously, John. Congrats. I thought, wow, unbelievable. Thank you so much. John Underkoffler. Thank you, John. Wow. John was so kind, and he said, okay, I can do one more thing for you, and I can leave a sensor. He left a sensor over there. So if you lift up your arm like that, please do it. I'm not joking, I'm serious. Okay, just lift up your arm like that. We can launch the next video. If you move a little bit on the right. I'm joking, come on guys, you know me.